So in this video, we are going to learn how to name alkanes using the IUPAC system, the International Union for Pure and Applied Chemists. There are two ways to name organic molecules. There's the common name and the IUPAC name. We're going to focus on the IUPAC name right now. The first thing you want to do is try to find the longest continuous parent chain. What do I mean by that? Well, if you have a molecule, let's just do this skeletal structure here. All right, you see, remember how we said you put your marker on one end and you just go as many carbons as you can without stopping. All right, so I'm going to go through this and I count how many carbons there are. 1, 2. Remember, the hydrogens are there. I'm not showing them right now because I don't want to clutter it. This is just a skeletal drawing. If it was a line drawing, it would have been 1, 2, 3, 4, 5, 6. So it would have been 1, 2, 3, 4, 5, 6. This is a line drawing. This is a skeletal drawing. If it was expanded, we would have put all the hydrogens there. If it was condensed, it would have been CH3, CH2, CH2, CH2. You get the idea. Anyway, first step when you're trying to name something is to find the longest parent chain. Okay, the reason we need to do that is that it depends on the number of carbons, and the number of carbons will tell you what the name is going to be. If it's just one carbon, it would have the prefix meth, M-E-T-H. If it's 2 carbons, it would have the prefix F. If it's 3 carbons, it would have the prefix prop. Okay. 4 carbons, prefix bute, not but, bute. 5 carbons, pent. 6 carbons, hex. 7 carbons, hept. I'll put it over here. 8 carbons, oct. 9 carbons, known. 10 carbons, dec. All right, so we counted these 1, 2, 3, 4, 5, 6. These are 6 carbons, so we're going to use the prefix hex. And the suffix, the end, is always going to be ane, A-N-E. So since this is a 6-carbon molecule, it's going to be hexane. Okay, that's the parent name. All right, so there are a whole bunch of rules, by the way, so hang in there. Whole bunch of rules for this. But the first rule is to find the longest parent chain. So if I had something like this, pretend all the hydrogens are there. All right, this is just a skeletal structure. Longest parent chain. So you start at either end, okay? And remember, you go through all the carbons without picking up your pen. So if I start here, let's say I'll go 1, 2, 3, 4, 5, 6, 7. I'd have to pick up my pen to get this one, so that's not part of the parent. I have to pick up my pen to get this one, that's not part of the parent. These two things that are attached to the parent, they are called substituents. Substituents, okay? Or they sometimes call them branches. So this would be a branched molecule because it's got stuff attached to it. All right, so based on our prefixes, what would this parent be called? It would be, since it's 7 carbons, it would be a heptane. Now we need to name these guys. This, anytime you have a 1 carbon branch, it's called a methyl group. Okay? If it's a 2-carbon branch, let's say I had something coming off of this that had 2 carbons. This whole thing, 2 carbons attached to a parent, this would be called an ethyl group. 3 carbons is called a propyl group. Now there are 2 types of propyl groups, and we'll talk about this a bit more in a second. There's a propyl and there's also an isopropyl, and I'll tell you the difference between them. If you have a 4-carbon branch or a 4-carbon substituent, there are 4 different types of 4-carbon substituents. There's a butyl, a sec-butyl. You have to underline the sec. There's a tert-butyl. And then finally, I don't know if you'll be able to see this. Let me move this a bit. Finally, there's an isobutyl. All right, so substituents. These branches, they are called alkyl groups. It's a big category called alkyl groups. These alkyl groups are carbon-containing branches that come off of the parent. So the parent is easy. The parent is a heptate. And now we need to identify these substituents that are on the parent. Well, if this is just a 1-carbon substituent coming off of this, this would be a methyl group. This is a 1-carbon substituent coming off of this. This is a methyl group. This one over here, can you see that it's 2 carbons? So this would be an ethyl group. Okay? The next rule, aside from finding the longest parent chain, circling all the substituents, the next rule is to number your alkane, number your molecule, so that the substituents, the carbons that have the substituents attached to them, get the lowest possible number. Okay? So if we number in this direction, this would be a 1, 2, 3, 4, 5, 6, 7. You see here that at carbon 3, you have 2 substituents, a methyl and an ethyl, and then you have 1 substituent on carbon 5. All right. If you number it the other way, this would be 1, 2, 3. So you still get a substituent at 3, but you only get one of them at 3. And then this would be 4, 5, 6, 7. So you choose the numbering that will allow you to hit a substituent at a low number and to have as many substituents at a lower number as possible. So when we name this thing, we're going to name the substituents. We're going to put the number, put a dash, put the name of the substituent. So this is what you're going to do. You're going to write, and you're going to alphabetize. So you're going to number, and you're going to alphabetize. What do I mean by alphabetize? Well, methyl starts with an M, ethyl starts with an E. So E comes before M in the alphabet, so it has to come before M in the name. So let me erase all this so it doesn't look so cluttered. And let's try to name this thing. If you have 2 of the same type of alkyl groups, because we already said that this is a methyl and this is a methyl, you have to tell me where both of them are, and you have to use the prefix di to indicate that you have 2 of them. So these are methyls, this is ethyl. We already said that we have to alphabetize, so ethyl comes before methyl in the name. So we're going to write down where this ethyl group is. So we're going to write 3-ethyl. Because this tells everybody that you have an ethyl group on carbon number 3. You always have to put a dash between a number and a letter, always. Okay? And then if you have a letter and you're going to put another number, you also have to have another dash. So go 3-ethyl dash. Now our methyls are on carbons 3 and 5. You put commas between numbers. So we're going to put 3, comma, 5 dash dimethyl, because we have 2 of them, and then you just squeeze in the name heptane. I don't have much room here. I'll just write it like that. Okay? And that's the name of this thing. You just named your first IUPAC naming of your first organic big molecule. Okay? 3-ethyl 3,5 dimethyl heptate. Okay? We'll practice a whole bunch. And you've got lots of homework to do that'll help you practice, but I'll give you another one in the next video. Okay? All right.